So my name is Carl Evans. I'm founder of Tercero Technologies. We're an AI startup based in Chicago. I'm here to talk about our phase 2 SBIR work. Cool. We're funded by PM Intelligence Systems out of Marine Corps Systems Command. And we're doing work basically applying artificial intelligence to electronic warfare systems. All right, so as we all know, there's an AI arms race between the US and some of our near-peer competitors. So as a result of this, DoD will invest billions of dollars in AI research and development, particularly related what we're interested in, smart sensors and autonomous vehicles. And then the JADC2 concept will lead to new capabilities being introduced to the Internet of Battlefield Things. But as a lot of those capabilities are powered by batteries, size, weight, and power becomes increasingly important to increase mission duration. So at Tercero, we're developing technologies to allow FPGAs. So FPGAs are reprogrammable chips that can be used for machine learning inference. We're developing tools that make it easier to use FPGAs for edge artificial intelligence, so that we can get new AI capabilities to the warfighter much more quickly. Quickly about me and the company. So Tercero, I founded Tercero in 2019. Currently have 2 employees with plans to double our headcount over the next year. My background is as a EE and a roboticist. In addition to my graduate degree in engineering, go Gators, I have an MBA in JD, and then I was the founding chair of the Joint Architecture for Unmanned Systems Working Group, which is now part of SAE. And you'll see through the work that I mentioned, we're really big proponents for MOSA, so open systems architectures. So our phase 2 SBIR effort, so we're currently funded on our phase 2 option, and looks like we're going to be transitioning to phase 3, which is great. But we have 2 key innovations. So we have a software tool that will convert machine learning models to efficient FPGA hardware designs. So for those of you who have worked with FPGAs in the past, you know that this process can take quite a bit of time, so we're able to automate that. And then the first application of that tool is a machine learning-based target tracking system, so we can track targets at the tactical edge. So why FPGAs? So like I said, FPGAs are reprogrammable chips where you can basically reprogram the gates within the chip. But FPGAs provide significant benefits over competing technologies such as CPUs, and I'm sure we've all heard of GPUs being used for machine learning. So you generally get better size, weight, and power, so better power efficiency, so compute per watt with FPGAs. You get better latency, particularly with low batches. So GPUs are really good at large batches. That's why they're used for machine learning training. But when it comes to small batch sizes, FPGAs generally provide better inference throughput. You get better determinism. So when you design a circuit with an FPGA, it tells you how long it's going to take for that operation to execute, and it's generally going to take that amount of time, whereas GPUs, it can vary. You get a lot of flexibility. So the FPGA with the whole chip, or most of the chip being reconfigurable, you can reconfigure the chip to execute different algorithms. The I/O for the chip is reconfigurable. And then a big thing for the DoD is it helps reduce obsolescence risk. So because the chip is reconfigurable, you can change your architecture. So if there's a new type of machine learning model that we come up with in a couple of years, you can reconfigure the FPGA to execute that model. And then something that you guys might have seen, some of the older chips, the Intel and Motorola chips that are no longer made, folks are configuring FPGAs to basically emulate those chips. So you have a lot of reconfiguration, or a lot of flexibility when it comes to FPGAs. And then a big thing for us, because we're doing edge artificial intelligence, is security. So there's hardware encryption, secure boot, and then anti-tamper capabilities. So the ability for the device to wipe itself or to essentially render the bit streams, the FPGA bit streams, unusable. So how are we commercializing the work that we're doing under this SBIR effort? So we're creating a product called Tercero, which is the tool to automatically, Acelerado, which will automatically convert the machine learning model to FPGA hardware designs. There are a number of different applications that we're focused on. Initially, tactical radar systems and electronic warfare systems, but we have applications that we're working on in unattended ground sensors. My background as an autonomous vehicle engineer, so we're going to be working on autonomous vehicle perception, multimodal sensor processing. And then again, FPGAs provide better compute per watt than GPUs. So let's talk about the challenge for this SBIR topic. So when the original topic came out, it was for this electronic warfare system problem, basically tracking targets in the presence of high volumes of sensor data. But then I extended that to work on so we decided we're going to do this with FPGAs, and then we developed the tool that I just mentioned to solve this problem of deploying a machine learning model for EW systems. So the challenge for this topic, EW systems can generate billions of data points per minute, so large volumes of data. So how can we filter essentially the signal from the noise? How can we, of all the data points that are being generated, how can we track potential targets from that large volume of data? And how can we do that at the edge for a battery-powered system? So our solution, we call the Acelerado preprocessor. It's able to track relatively slow-moving targets, so up to 40 miles per hour, in the presence of high volumes of clutter. And we have a performance target of less than 5% false alarm rate within a 24-hour period. It needs to be able to integrate with electronic warfare systems, such as the MOD-2 that I had on the previous slide from Sierra Nevada. And then all of that needs to fit within a relatively small package of 12 inches by 6 inches by 4 inches. And then I mentioned open architecture. So we also support the GICD 4.2 standard, which is used in the intelligence community and other DoD applications as well. So current status, this is as a few months ago. This is what we were approved to show publicly, but we have an application. It's a web UI where a user can upload a TensorFlow model or Onyx model, select the target hardware. So the nice thing about this is it's very easy to change from different FPGA hardware by selecting one of the radio buttons there. And then choose a number of build options, quantization. We do some automatic model optimization and tuning, and then press submit. And then the process is completely automated. And depending on the model size, anywhere from a few minutes to maybe a couple of hours, the output will be an SD card image that you can load in a development board and test out your model on actual hardware. So we are developing what we call the Acelerado preprocessor. So that's the hardware device. It's changed slightly over the past couple of months. And then we have a tablet UI that shows the filtered, basically the results of our inference. So it shows where we have identified potential targets. Okay, so for phase one, for phase two, we have the tablet. For a phase two option, which we're working on now, we're going to be doing visualization using the Microsoft HoloLens. So transition opportunities. So the first transition opportunity is the MEGFOS program, which I'm excited to announce that last week we were just notified that we are transitioning to this program of record. So very excited about that. And then we're also looking at other DoD opportunities, like I mentioned before, ground sensors, unmanned vehicles. We're looking at licensing the technology. And then we're currently looking for phase three partners. So we're teaming with, we're having conversations with folks that do software-defined radios and EW systems, particularly those who are using Xilinx FPGAs. We're starting to raise a round of $1 to $1.5 million so that we can demonstrate technology to other DoD customers and then some of our commercial customers as well. Perfect timing. So thank you very much. And feel free to stop by, and I'm happy to talk about the technology.